Hello, everyone, and thank you for joining the Institute for Carbon Removal Law and Policy's latest webinar. My name is Will Burns, and I serve as co-director of the Institute, which is a research center at American University in Washington, D.C., which focuses on the science, the technology, the law, policy, and ethics of the rapidly emerging suite of approaches and technologies that we call carbon removal or carbon dioxide removal. And because our focus today will be on California, I'm pleased to introduce a co-convener today, Bruce Reardon, who serves as director of the Berkeley Carbon Removal Network. And I was wondering, Bruce, if you could just briefly introduce yourself and the network's work.
Great, thanks, Will, and good afternoon, good morning to all of you out there. I run something called the Berkeley Carbon Removal Network. It's about 40 researchers, both on the campus at UC Berkeley and up the hill at Lawrence Berkeley Lab. We look at, obviously, federal and state funding opportunities and new things like the X Prize. We work on collaborative research because we draw from across the campus a number of different disciplines, including the law school that you'll hear from today. And we work on both natural and engineered solutions to this big topic. So happy to be with you. And Will, thanks for making me a co-host today.
Thank you very much, Bruce. So as indicated previously, today's webinar will focus on the potential role of California in helping to both effectuate and drive diffusion of carbon removal technologies and processes in society. To help us discuss this topic, we have authors of two recent publications that are pertinent to this topic. First will be Ethan Elkind. Ethan serves as the director of the climate program at the Center for Law, Energy, and Environment at UC Berkeley Law, as well as the Climate Change and Business Research Initiative on behalf of UC Berkeley and UCLA's schools of law. Ethan was the lead author of a report published late last year entitled Capturing Opportunity, Law and Policy Solutions to Accelerate Engineered Carbon Removal in California. Our second speaker will be Sam Uden, who is the Manager of Conservation and Climate Policy for the Conservation Strategy Group in Sacramento, California. Sam recently published a piece in the journal Joule, which critiques the use of integrated assessment models to assess the potential for carbon removal and suggests that a bottom-up approach may provide a more realistic snapshot of carbon removal viability across a range of jurisdictions. And among the case studies that he focused on was one in California, and he will discuss that in his presentation today. We had contemplated a third presentation by Maya Batras with ClimateWorks. However, due to an emergency, she is unable to participate in today's event. We will proceed with two 10 to 12 minute interventions by our respective speakers, and this will be followed by a Q&A session, primarily fielding questions from the audience. And so with that, I'd like to turn it over to Ethan.
All right, thank you so much, Will and Bruce and everyone at the Institute for helping to organize this event. Really happy to have an opportunity to chat about this topic. And as Will mentioned, most of my remarks here are going to be based on the report that we issued in December of last year called Capturing Opportunity. And that's available on our website at clee.berkeley.edu. It was also co-released with the UCLA Emmett Institute on Climate Change and the Environment and sponsored by Bank of America. So just full disclosure on all the partners involved in that work. But you can find a lot more detail online in that report. But first, I want to talk, so I'll talk about some of the challenges in California, why we are focused on engineered carbon removal or trying to get more focused on engineered carbon removal. So I'll talk about some of those challenges and some of the policy needs and also some of the context for why we're talking about it. So first, to talk about the context, why we need carbon removal. And for those of you who are already fans and familiar with Will's Institute, you probably don't need to hear this, but in terms of the California specific context, California has aggressive greenhouse gas reduction goals under first AB 32 and then SB 32. AB 32 required that we get our carbon emissions by 2020 down to 1990 levels, or back to 1990 levels. We've already exceeded that. And then out to 2030, we need to further reduce emissions 40% below 1990 levels by the year 2030. So that's the SB 32 goals. So we're already trying to do a lot to mitigate as much as we can and reduce emissions from our primarily from our energy and transportation sectors in the state. But beyond that, we also have an executive order in California that former Governor Jerry Brown proclamated that we need to be carbon neutral by the year 2045. Now, Governor Newsom has asked the Air Resources Board, the primary agency responsible for achieving this target, to look into possibly accelerating that target to 2035. Is it feasible for California to be carbon neutral by 2035? And then beyond these dates of either 2035 or 2045, we need to have negative emissions in the state going forward beyond that. So the only way that we can achieve these carbon neutrality goals in the state, let alone making full progress on mitigation, is to sequester carbon in some form or another. So there are a lot of nature-based options that the state is exploring. I mean, essentially using our natural systems, primarily our forests, our plants, agriculture, et cetera, to pull carbon out of the air and find ways to keep it sequestered in the soil underground. But we know we're also going to need some engineered technologies, and we need to get these deployed as soon as possible, envisioning the scale of the deployment that we'll need over the medium and long term here. So in terms of how we would define engineered carbon removal, so basically it's in two buckets. So the first would be negative emissions, where we actually are pulling carbon dioxide out of the air, either through direct air capture or potentially through biomass type sequestration. So that would be negative emissions. But then there's also avoided emissions, where we would take carbon dioxide, other greenhouse gases that would come out of smokestacks, basically, but capture them at those smokestacks and then bury them underground. So that's another way to think of engineered carbon removal as avoided emissions, not just negative emissions. I said that they could be sequestered underground, so that could mean things like oil fields that have caverns underground where we could sequester them, salt domes, things like that. But also they could potentially be sequestered in products as well. So concrete would be one example, even plastics. There's a lot of exciting potential for innovation in terms of what we could do with that carbon dioxide once we have it captured. Now, fundamentally, engineered carbon removal is about waste management. What do we do with all the greenhouse gas emissions that are already in the air or that are coming out of our facilities? And so it's different from other types of climate change, clean technology type deployment, like renewable energy or electric vehicles. Those are more about mitigating emissions. This is really about dealing with the waste, in this case, all the greenhouse gases up in the atmosphere, the excess greenhouse gases in the atmosphere that we need to deal with. Now, there are some really promising co-benefits that could come with deployment of engineered carbon removal technologies. I mean, primarily, it could really help with what we call the just transition in California. I mentioned that oil fields could be a great spot to sequester carbon captured from the air. That is a perfect spot to help scale up new industries as we think about hopefully phasing out fossil fuel production in the state over the coming decades. And for those communities, I'm thinking of Kern County, for example, which has about 90% of California's fossil fuel production. If we shut down our fossil fuel industry, we're going to see tremendous job losses and economic impacts in those areas. And so finding a new industry with carbon capture as a transition point for good paying jobs would be really helpful, not just in terms of the lives that would be benefited in these communities, but also just in terms of California's economy, and then just thinking about the political ramifications of our overall transition to a carbon neutral economy. It would make it a lot easier politically if we have industries waiting for people to transition out of fossil fuel jobs. So those are some of the real upsides for engineered carbon removal. But definitely they are not without controversy. And just to address some of the key points that we often hear raised around engineered carbon removal in general, a lot of people are concerned that this becomes an excuse for avoiding hard choices on mitigation, That, in other words, this is an excuse not to continue with robust efforts to decarbonize key sectors like energy, electricity grid, like transportation. So that's one excuse that, or one concern that you hear a lot, is that these will be essentially an excuse. But as I mentioned, we have to really do both as rapidly and aggressively as possible in California, both mitigate and start to scale up our carbon removal for these net zero goals that we have in the state. Another concern is that this will allow industrial facilities to essentially keep polluting, because even if you're capturing carbon at the smokestacks, are you then not capturing other pollutants that are damaging some of the local communities? And often these are environmental justice communities where industrial facilities tend to be located in the state for reasons of essentially racial discrimination and the fact that wealthier communities don't want to see industrial facilities in their neighborhoods. So that is a big concern, an environmental justice concern. I know that if Maya was here on this panel today, she would be speaking to this concern. A third controversy around engineered carbon removal is that it becomes a way to enhance oil recovery, because one of the ways to sequester carbon is to essentially inject it into oil fields to pull more oil and gas out of those oil fields by using carbon essentially as a gas to push out other fossil fuels. So while it is carbon sequestration on one hand, if you're using it to boost oil recovery, that's a potential problem. It negates some of the carbon benefits and continues with some of the localized pollution that impacts environmental justice frontline communities. And then finally, another controversy I'd mention is just around biomass and the challenge of, are we just going to be facilitating a biomass industry that has a form of carbon removal by the biomass emissions being buried, but then it becomes an excuse for deforestation, endangered species impacts, et cetera. So just to highlight some of the controversies there. But in terms of California specific challenges to getting these facilities deployed and try to do so in a way that avoids some of the controversies that I just highlighted, in California, we've identified 4 primary challenges to deployment, at least of kind of early stage engineered carbon removal facilities. So the first challenge that came out of some stakeholder outreach that we conducted is that the state lacks a clear statewide strategy for deployment of engineered carbon removal. We have some aggressive goals like a decarbonized electricity grid by 2045 under Senate Bill 100. We have a cap and trade program that seeks to reduce industrial emissions primarily of carbon. We also have a low carbon fuel standard, but all these programs are not acting in a coordinated, clear way to help facilitate optimal deployment of engineered carbon removal. So that's one challenge at the state level. The second is that we have a very uncoordinated, unclear, and decentralized permitting regime for these facilities. And anyone familiar with trying to get any project built in California could probably say, well, that's true of any type of project, but it's particularly acute when you have a new technology like engineered carbon removal facilities. And in this case, you've got federal jurisdiction in some cases, you've got state jurisdiction, local jurisdictions, and you don't have a very consolidated, clear process for permitting, which really inhibits investment. Investors really detest uncertainty. They don't want to see that they've sunk a lot of money into a project only to find that there's some random agency out there with a veto power over the project that they didn't anticipate from the outset, or that the permitting process is dragging along because you've got different timelines for different agencies who maybe aren't sharing information and aren't coordinating their decision making. A third challenge that we identified is a lack of public awareness around carbon removal, engineered carbon removal in general. And so therefore it's hard to get the public either motivated to support this kind of a project or aware of what to ask for when it comes time to permitting. So boosting public awareness around engineered carbon removal and improving outreach on that front is a clear need. And then the last challenge that we identified with our stakeholder outreach is just general financial uncertainty around investing in these facilities. And primarily that's financial uncertainty that comes from the different state and federal incentive programs, which are otherwise relatively generous, but operating on different timelines and with different conditions that make it really challenging as well. So some of the solutions that we talk about in our report, again, you can find it on our website, clee.berkeley.edu. I'll just highlight 4 areas of solutions on each of these key challenges. One is that we need some state leadership on deployment. And that would mean starting with potentially an executive order from the governor with some targets for engineered carbon removal deployment, maybe a certain number of tons of removal or number of facilities. We also need to figure out a single point of contact in the state government that could be a lead agency, essentially for shepherding the permitting of these facilities and to help coordinate an overall state strategy on engineered carbon removal. Because right now it's not even clear who, for example, would be the lead agency on the environmental review for an engineered carbon removal facility. Would it be our state's oil and gas regulator, or the Office of Planning and Research, or the Air Resources Board, or the local permitting agency? We really don't even have clarity on that. Secondly, in terms of solutions, we need a master permitting process. We need to make sure that all the permitting is coordinated from California's environmental review to our endangered species laws and our oil and gas oil drilling wells, for example, which are essentially the wells you would have to drill for burying carbon as well. And there's some legal issues associated with the permitting process that also need to be addressed. Most prominently, clarifying in California specifically who owns the pore space, the subterranean pore space where the carbon would go. It's not clear who has the rights to that space. So some legislation is probably going to be needed to clarify that. Other states around the country have already clarified pore space ownership. So that's an area where I think we see some immediate needs for legislation. And as part of it too, what the state could do in terms of really streamlining and having a better process on permitting is identifying some of the key corridors in advance where they think engineered carbon removal will be most promising, most optimal for deployment. So maybe that's a Kern County, as I mentioned, that has all these oil fields out there already. And I say corridors because in some cases we may be capturing carbon in one place and then essentially piping it to another spot for sequestration or burying it in, or sequestering it in some kind of product. So that's all part of the sort of master permitting piece of it. Third, we would talk about improved outreach and pilot projects. It'd be really great if the state could get behind a demonstration project or two and get some data on the benefits and the potential risks for communities, so we have a better sense of what the upsides and downsides might be. And that could also help dispel some of the concerns around the technology. And then lastly, we talk about reforming some of the incentives and the infrastructure available for these projects that would help address some of the financial uncertainty. So that could mean things like extending the carbon intensity limits under the low carbon fuel standard beyond 2030. It could mean transitioning or coming up with a plan to transition some of our natural gas infrastructure to instead transport carbon. Also extending at the federal level the 45Q tax credit and harmonizing and extending the construction deadlines, which right now have different tracks under the different state and federal programs. And the more time we give developers, the better from their perspective to build in uncertainty. So again, just some of the solutions that we talk about, but otherwise, this is an area where California does have an opportunity to continue its climate leadership on engineered carbon removal, but a lot of these questions need to be answered if the state has any hope of meeting this long-term carbon neutrality goal that we have. So I'll stop there and happy to hand it over to Sam and look forward to Q&A later. Thank you.
Great, thank you. Thank you very much for that, Ethan. Let me say at the outset, Sam had some difficulties in terms of his internet, so we have jury-rigged this, and he's coming to us via FaceTime, and Jen Brown in our office will advance the slides for him. We hope it'll all work out.
Will, let me just throw in that to remind people we're using the Q&A function. So type your questions in and we'll get to some of them after both speakers. But also, Ethan, there's some questions just about the report that you might want to answer in the Q&A box as we go here. Okay,
will do. Thank you.
All right. Okay, Sam, all yours.
Okay, over to me. Thanks. Yes, I ran into some true COVID era technical difficulties this morning. High stress, but you're right. As you said, we've rigged something up, and I hope this comes through clearly. And appreciate the opportunity to talk today. So as Will mentioned, my name's Sammy Dan. I work on carbon removal policy in California for a consulting firm called Conservation Strategy Group. And today I'm going to present on assessing the role for CDR, carbon dioxide removal, in achieving net zero in California. There'll be two parts to the presentation. The first part, I'm going to summarize a paper that I recently published in an energy journal called Joule. And then secondly, I'm going to relate the findings from that paper to some of the day-to-day policy work I do in Sacramento. And just as a quick note, when I refer to CDR or NETs being negative emissions technologies, I'm referring to the engineered solutions, including bioenergy with carbon capture and storage, BECCS, and direct air capture, DAC. So appreciated Ethan sort of clarifying some of those terms in the previous presentation there, make my job a bit easier. Okay, Jen, you can go to the next slide. Okay, so the Joule paper is titled Cutting Through the Noise on Negative Emissions. And so the background is it's a perspective paper that challenges a common perception that nets are a risky backstop technology, which we define as the collection of arguments that nets are risky to rely on as they are unproven, which is there are some claims, deter near-term emissions reductions and may transfer the responsibility for climate change to future generations. So they're important arguments, and you know, that opposition, you know, for want of a better term, could come from many places. But you know, what we highlight in the paper is that this opposition is often based on the results of integrated assessment models. And so, for those that I should probably define, so they're the global scale models that are the basis of IPCC reports, but also other reports that try and chart a course of the certain combinations of mitigation actions to achieve a global warming goal of 1.5 or 2 degrees Celsius. So the background here is that in 2014, when the IPCC released its 5th assessment report, almost all the modelling scenarios that stabilise global warming at 2 degrees Celsius required a late century, large or mega scale deployment of nets. And this resulted in a, you know, kind of a burst of literature that called for caution, that called this this strategy a high stakes gamble, and that nets were a bet that we had to make sure was safe to take. And so, you know, these kind of claims substantially shape the discourse around how we should be thinking about nets, and they're important points. You know, but the sort of the basic argument that we put forward in the paper is that, you know, models are not real life, and in many cases, these arguments are based on long-range forecasts out to 2100 that there's no guarantee at all. In fact, it almost certainly won't come to pass in that way. And in fact, what we show in the paper is that a number of assumptions in the models that created that late century large scale nets deployment archetype are arbitrary, and in fact, some cases controversial. For example, allowing the ability to overshoot 2 degrees Celsius to then have tens of gigatons per year removal in the end part of the century. And they're assumptions that you don't see in the latest iteration of IAMs, where they sort of disallow or have limited or low risk possibilities of overshoot. So from our perspective, this sort of underscores, I guess, the fragile basis of crafting an opinion around a mitigation option, nets in this case, based on these global scale models. And so we, you know, use that as a basis to argue in favour of and explore the role for bottom-up approaches or methods. So to, in other words, assess what are the different technologies that make sense at jurisdictional or decision-making scales. So a state or a country scale. Okay, next slide, Jen. Thanks. Just setting my papers up here. Okay, so in this slide here, so in the second part of the paper, this is what we introduce. We introduce a 2x2 framework to make these bottom-up or jurisdictional scale assessments of negative emissions technologies and whether they should or should not be deployed in a jurisdiction. It's a screening tool. It's a high-level screening tool. You can see the traffic light. You know, if you're in the green, it seems nets may be an option that you should invest in and keep on the table with the potential of offering climate benefits. Yellows are, you know, possibly, and then red is, it doesn't seem like it's a good fit. So I'm just going to quickly walk you through this diagram here, which is a central part of the dual paper. So on the horizontal axis, this is the zero carbon, what we call the zero carbon availability axis, which measures the relative availability of zero carbon options. That includes wind, solar, nuclear, hydro, and geothermal that are available in a jurisdiction to achieve a certain mitigation goal. So the key point here is that not all countries have, for example, high wind and solar potential or high land availability for projects, or there may be low social acceptance or aversion to some options. For example, nuclear is an obvious example there, or there may even be limited regulatory support for certain options. So the horizontal axis at a higher level aims to aggregate this information for a jurisdiction and plot a jurisdiction somewhere on the horizontal. So the idea being, if you have a scarcity of zero carbon options, nets would appear to be a more valuable option to look at to achieve a certain mitigation goal, for example, net zero. Okay, so the vertical axis is what we call the benefit cost axis, which measures the social and environmental benefit or cost of deploying nets. So, it might be the case, so the idea here is that it might be the case that, sure, you have a scarcity of zero carbon options, but that doesn't mean deploying nets is necessarily good for society or the environment in your jurisdiction. So we try and get a measure of that here. So just as an example, and picking up on what Ethan just described about biomass, does your jurisdiction would they have to grow a substantial amount of energy crops that can compete with conservation or agricultural lands and result in costs and uses of water and cost of biodiversity protection? That would be, we would consider the cost in this framework. Another example could be if you have a large oil, again, this is picking up another one of Ethan's points related to the just transition. If you have a large oil and gas sector existing that's sort of at risk given efforts towards a clean energy transition, a nets deployment could create transferable job opportunities in CO2 storage and CO2 pipeline construction, which would provide a social benefit to the jurisdiction. So in summary, the idea here is if you have a scarcity of zero carbon options in a jurisdiction, and it's possible that nets could create a benefit to society and the environment, then they're an option that's worth keeping on the table in investing in with a view to scale them over time as needed. Okay, next slide. Thanks, Jen. Thanks. So, and as Will mentioned at the start, we applied this framework to a couple of case studies. One of them was California, and we found, or is our view, that California is likely to be in the green square of our framework. So California has some zero carbon scarcity. This is the horizontal axis. There is, at this stage, no new nuclear or hydropower planned. California has relatively limited wind potential compared to other jurisdictions. These are the zero carbon options. It has mixed regulatory support. So on the one hand, there's great ambition in California to achieve climate goals, but on the other hand, California has established programs. For example, there's a program at the Resources Agency focused on cutting the green tape, such as the administrative difficulty with doing projects in California. And we say there's also mixed social acceptance in California. Again, a lot of California residents are really interested in aggressive climate action, but at the same time, there is a history of, the term is NIMBYism, which is, I want the project, but could you build it somewhere else because it might affect, house prices and things like that. So, so we consider it to offer mixed social acceptance. And California also has a lot of hard to abate sources. So, for example, animal agriculture and methane emissions, aviation, shipping. These are things that hard to abate, hard to electrify. And overall, we consider California, to be clear in the report, we consider them to have sort of an adequate zero carbon, sort of towards the middle of the zero carbon availability axis. And that's the justification for why. The second point, this is the vertical axis, the benefit cost axis. it's and very possible that California could realize substantial co-benefits as part of a NETS deployment. So in the case of California, California has an abundant amount of waste biomass. So that is forest residues, agricultural residues from the Central Valley, and municipal solid waste, tens of millions of tons a year that are pile burned, sent to landfills, or left to decay in fields. But this creates very high short-lived climate pollutant emissions in the form of methane and black carbon, which are often known as super pollutants. So if it was possible to divert this waste that otherwise goes to those end users, you could avoid those emissions and also improve air quality, particularly from minimizing agricultural burning. So that's one potential benefit. Another one is to fund forest management. So as everyone I'm sure knows, in fact, it's smoky here today in Sacramento, the American West has a wildfire problem, and a key driver of that is a history of fire suppression that's resulted in forests being dense and overgrown. And so there's a need to reduce fuels, fuels being sort of the small diameter trees that, for want of a better term, clog the forest floor and sort of the tinder for the catastrophic fires that we see. The state has set goals around this to rapidly increase its forest treatments, which is going to result in hundreds of millions of new tons of biomass waste each decade. Some recent research UC Berkeley has been working on has been looking at that. So if it was possible to take this waste that's going to accrue as a result of the state's goals and put it into BECCS systems, create renewable fuels, do carbon capture and storage, that's a way you could support the cost of forest treatments and reduce wildfire, and at the same time, by improving forest health, increase water supply to the valley floor. And California is also in a drought. So that's also, and the Sierra Nevada is a very important watershed. So that's another point. And finally, I'm just conscious of time. I may have gone a little longer than I anticipated to. The job creation and economic development benefits associated with BECCS and DAC projects. So I've talked a bit about the kind of BECCS pathways, but direct air capture. California has a lot of unutilized geothermal resources in various parts of the state, and these geothermal resources can be coupled with a certain type of direct air capture to create renewable direct air capture. So you don't have to burn natural gas to power the direct air capture. These geothermal resources are not hot enough for profitable electricity production, so they're just currently unutilized. So if it was possible, and we've had some early discussions with different stakeholders, to couple DAC to these geothermal resources, that could create potentially substantial economic development opportunities in regions that are disadvantaged and low income, which is typically where these resources are located. So that's a very nascent idea, but it just is an indicator of the potential, and so I wanted to highlight that point. Okay, Jen, you just want to go to the last slide, which I'll very quickly go through. There's a lot there, but I wasn't planning on going through it in detail anyway. So I'm just really bringing us right in now to the day-to-day work that I work on with Ethan and others in Sacramento. I'm focusing on the forest BECCS potential pathway. So just as a quick summary, the diagram you're looking at here is the supply chain of a forest biomass to fuels with carbon capture and storage. A potential pathway that could exist. If you sort of consider this pathway on paper, it is commercially viable. But as Ethan alluded to, there are a number of kind of real world barriers that are in place that prevent this. For example, a developer, a gasification plant, a developer coming in and saying, I'll build a plant in California. And so our work has been to think about what are the barriers and how can we overcome them to unlock this pathway and make it work. And so without going into all the pieces, I'll just highlight three main ones here very quickly. the big three I've got to the bottom there. One is feedstock supply. So one important point to note, I'm conscious I'm talking to a national audience here, is that in the American West, the forest ownership is very different to other parts of the US. There's a significant amount of federal lands, federal forest lands. It's very difficult to enter into a long-term feedstock contract or arrangement with the federal government. And this means you sort of can't pass go. If you're a developer, a key requirement to raise some financing to build a plant is you need to be able to demonstrate access to long-term feedstock supply. And right now, it's just about not possible to do that on a moderate scale from federal land. So that's one issue that this group of people are looking at in California to try and resolve that issue, which really relates to the American West. Another one is the low carbon fuel standard, is a state program in California that provides incentives for biofuels production. Right now, there's no approved forest to biofuels with carbon capture pathway under that program. So, and that presents a high barrier to entry for an potentially interested developer. So thinking about how the Air Board can adopt some sort of simplified life cycle calculators to reduce that barrier. And the last one is CO2 storage. So, and this, I'm sure some people in the listening know, a bioenergy company, doesn't usually have a geologist on staff that are experts in CO2 storage or CO2 transport. And so despite available incentives, the prospect of taking on that new function presents a really high risk to these businesses, and sort of sufficiently enough that even great incentives cannot be enough to get them over the line. But if it was possible, from our discussions we've had, they're interested in doing carbon capture if it was possible to pass off the CO2 for someone with expertise in that function to store it underground and manage it into the long term for its permanence. And so we are working on considering how the state could adopt that role in California. Again, early discussions. And in particular, whether the state could finance, build and operate a CO2 storage hub for public benefit. So I've gone way over time, I think, I'm sure, but I'll stop there. That's the end of my presentation. Thanks a lot.
Okay, thank you very much for that, Sam, and thanks, Jen, for making it happen. We will now move to questions. As always, we have some excellent questions from the audience, and I'll let Bruce kick us off with those.
Great, thanks, Will, and thanks to both of our speakers. First one, Ethan, let's put another plug in here for the Getting to Neutral report about California. So the question being, what's the basis, the scientific basis for, or the claim, or political basis for the claim that in California we're going to have to do engineered carbon dioxide removal? Can you talk about that and maybe reference the Getting to Neutral report?
Sure. Yeah, and I guess, saying required, there's nothing statutorily required about engineered carbon removal. I mean, in fact, that would be maybe one of our recommendations, as part of the state's leadership on this, that the governor set some targets. That was my earlier point about an executive order. But so it is true, we're not statutorily required to use engineered carbon removal. We don't know how we're going to achieve carbon neutrality. This is something that the California Air Resources Board is looking at now. I was referencing this Lawrence Livermore lab report, Getting to Neutral. Bruce, you just name checked, and I just put it in the Q&A chat as well, so you can see the link there. But that report really pretty methodically goes through the options that we have for carbon removal and talks about some of the, essentially, I don't want to say tried and true technologies, but the ones that we feel like we can rely on with a pretty good degree of certainty to meet these carbon neutrality goals. And as I mentioned, not all about engineered carbon removal. I mean, we're still very bullish on nature-based solutions and nature-based carbon removal. But I think engineered carbon removal has to be in the mix. If it's going to be successful, we need to get some demonstration projects out in the near term so that we can be ready for a larger scale deployment if these facilities have the kind of success that we hope that they will. And I think, Sam's presentation really showed just the diversity of carbon removal options that are out there. That's what I think is pretty exciting about this field. When you think of the range, everything from biomass, agricultural waste, all the way up to machines that would literally pull carbon out of the air and bury it or sequester it in products.
Great, thanks, Ethan. Question for both of you on the just transition. So the question in the box, could you please talk a bit more about the opportunity for a just transition and creating opportunities specifically for shifting the workforce from the fossil fuel industry to carbon dioxide removal?
Well, Sam touched on this, so I do want to let him go. I'll just say one thing, because we just did a report last year as well on phasing out fossil fuel production in California. And one interesting statistic or piece of data that came out of that is that the oil and gas workforce, at least in California, is actually skews on the older side. And so first of all, if we're just thinking about a phase out date of all fossil fuel production in the state, let's say by 2045, 2040, I mean, if we could send that signal now, we could basically be telling people, let's not start new jobs in this field. This field is going to be extinct soon. Let's let the people who are there have their union jobs, good paying jobs, let them kind of work through it. We'll slowly phase the industry down. So we do need a signal now. So I just want to say that one thing at the outset, that's the importance of having a long-term phase-out goal, is that you can get people to plan, you can get communities to plan better. As for the specific employment opportunities in engineered carbon removal, I mean, I think it's going to be cold comfort for people if you say, hey, look, we're hoping this new industry is going to replace a solid job that you already have now. I think that's a hard sell for Kern County. They're not going to say, oh, great, well, we'll just take your word for it and we'll start, not permitting any more of these facilities or finding a way to wind them down. So we can't say that at this point, but I think it provides enough promise that these demonstration projects will help inform not just the data on the community impacts, but the data on employment, et cetera. But I do want to let Sam touch on this because I know this is something that he's looked at a lot.
No, yeah, that was a great. I'll see what I can add. That was a great comment, I thought. I mean, I agree with Ethan's comment about it's kind of a long-term signal. I'm a bit of a path dependence guy. It's very difficult for any project developer to execute a project, but once they do, it's done. So if we can set long-term signals now to disincentivize new fossil infrastructure, that's critical to kind of get on the right path. But just in terms of some of the employment opportunities, I guess I'll just list a few things that come to mind. I mean, CO2 storage, so site appraisals so geologic site appraisals and assessing sites is an important job that needs to be done to think about, where can we safely and permanently store CO2 underground. Obviously drill rig construction, CO2 pipeline construction, CO2 storage, which is sort of very transferable from the oil and gas skilled oil and gas workers. Also, though, I would think about biofuels refining. So there are heavy duty transportation applications like planes and ships and things like that, which are going to be very difficult to electrify if ever possible, on a time period before mid-century. So transitioning, if we're converting waste that otherwise gets burned in piles to renewable fuels, it will be relevant to refine those fuels. So it's possible that refineries can move from fossil-based to more biofuels-based. The two comments I'd add to Ethan's point there.
Thanks, Sam. Okay, next question. We have some good ones in the box here. Can you discuss any suggestions you have for ensuring equitable distribution of CDR benefits and risks, particularly looking at disadvantaged or harder to reach communities? And the second question with that, are there any current California policies or programs about this? You both touched on it, but if you could expand a bit.
Well, I think the key is outreach and having processes that build in community engagement from the outset. This is why we talked about the recommendation that the state identify some key corridors in advance. Let's figure out some promising areas, either because of the geology or the existing facilities, or maybe the location to certain biomass feedstocks. Let's draw a map and start doing some outreach to those communities and start building in that process at the outset. I think that's the best way to try to ensure that we maximize the community benefits and minimize the negative impacts. Because, as I said, one of the controversies is that this will allow some industrial facilities to keep polluting, even if their carbon is captured, their other harmful air pollutants may not be. So, so I think the outreach and giving local communities a seat at the table as early as possible is critical.
Yeah, no, that's a fantastic question. And, I think I don't want to spend too long on the abstract here, but when I think about energy transitions, I mean, we have to fundamentally change the way we think about, the level of community engagement necessary to support a fast-paced and large-scale energy transition. And everyone knows this. It's the kind of the speed with which we need to deploy new technologies and that will kind of change landscapes is totally unprecedented, and we need new approaches that match the scale of what science says is needed. So I would just preface that, but I think it's a really important point. And as far as policies go, it's often the case that in policies there'll be prescriptions, particularly regarding grants and things like that, to consider define disadvantaged communities and others that can hopefully have access to available public funding as a priority, particularly for studies around environmental impact and things like that. So I think California does a pretty good job of that. But as I said, I think we need to think about improving on that in the context of almost a new paradigm for thinking about community and stakeholder engagement. I'm sorry, that's kind of an abstract answer, but just as one point, I've done some reading lately. In the UK, they're trialing this concept called citizen assemblies. I think it's Cambridge that is trialing it, where they're trying to, it's a sort of a bit more of a methodical approach to participatory project design. I think it's very interesting. I can't talk much more about it, but anyway, I just think it's an important point, and
Great, thanks, Sam.
Yeah.
Next question, is California willing to remove CO2 in non-California areas, for example, in the oceans? Sam or Ethan, either of you on that one? You can speak for California right here. Here's your chance.
Maybe I'll just quickly take myself off the table and say I'm not really sure about that. I mean, so California, we have when we say oceans, if we're perhaps thinking of things like blue carbon and mangroves, just vegetation like that on the coastline. California is in the middle of developing a sort of a formal nature-based strategy, which I'm quite sure is going to consider the role of blue carbon and some estimates for blue carbon, and that's designed to be rolled up into the scoping plan, which is the roadmap that the state is developing to get to net zero, which is currently going through the public process and is scheduled for completion towards the end of 2022. So within that, there's going to be a nature-based section that I'm quite sure is going to look at the role of blue carbon and put some estimates around that. But I couldn't offer more information than that.
Ethan, anything on that one?
No, I think Sam said it well. I mean, this is definitely kind of part of the process right now for the state to figure out how we're going to achieve it. But I agree with Sam. We've done some work on nature-based solutions as well, and oceans are definitely part of that.
Next question, Sam, could you please expand on mixed regulatory support in California as it relates to zero carbon?
Yeah, I can, and I should. Okay, I'll expand first and caveat second. So our view on the mixed regulatory support, which is a high level view, it's very difficult to kind of rigorously quantify that variable, is that California has a high ambition, lots of climate programs. The Air Resources Board is a kind of a very cutting edge, forward thinking agency trying to design new programs to support mitigation in the state. And it's in the state legislature. There's always new kind of cutting edge climate ideas that people are trying to come up with, and there's a lot of support for those. So sort of on a regulatory front, we say there's great ambition. So that's a positive. A negative is that there's sort of significant administrative and regulatory barriers to doing projects in California. So if you can, and to do with permitting and things like that, and the level of requirements needed. So if you almost, I sort of feel fairly confident to say that almost all project developers of different types of projects would say that, California's a powerhouse economy, we want to be there, but doing a project in California is very challenging because of all those requirements. And if you think about that in the context of what's needed, 10 times the amount of solar that we have, that we have today, and things like that to achieve the net zero ambition. I mean, that's why we say that there's mixed regulatory support. So high ambition, but significant permitting and other regulatory challenges for good reason. It's just that we're sort of entering a bit of a new era where we need to be able to go sort of fast and big and fair. And what does that look like? I'm not sure, but that's why we say mixed regulatory support.
Question on biochar. Do you consider biochar as part of engineered carbon removal? And if so, what's the potential for biochar in California?
Yeah, I can go first. That's a good question. I hadn't really thought about it like that. There's a lot of interest in biochar in California, and in fact, so Ethan and I are part of a state forest biofuels, volunteer working group, and one of the recommendations that we hope to come out of that group is for the state to formally develop a biochar protocol that could be credited under maybe a cap and trade or another program. I think there is a potential for biochar. Yeah, that's. But I guess it's tied into an engineered solution on the basis that it's often a sort of a product of conversion, like a gasification or pyrolysis. But I couldn't comment further.
Yeah, I would echo what Sam said. I haven't seen any particular estimates on the biochar potential, so couldn't comment on that. But yeah, I agree. There's a lot of promise with biochar.
So the next question on biomass from agriculture. Question: can somebody comment on the feasibility of utilizing biomass fuel sourced from agriculture? Are there feedstock quality thresholds that might prohibit common agricultural waste outputs from being used? So, Ethan?
Yeah, I think I mean, we have a lot of agricultural waste in the state, and I think it's pretty much not controversial to look at these as some prime feedstocks for biomass. Of course, we have to be concerned about air quality impacts, particularly in the Central Valley, which is a basin and a heavily impacted, polluted one. But certainly, burning these waste piles is not optimal. Having them decompose and methane is not optimal. So converting them to biomass energy, I think that there are sort of a prime feedstock. I think part of the challenge is really the economic one. There is actually some competing uses, and then the group that Sam and I were involved in, we heard that actually a lot of oil fields are using agricultural waste in the first part of their processes in the oil fields, which was kind of news to me. But I think just finding the way economically, I think that's a more important question and threshold need for how you would gather the feedstock, transport it, which facility is it going to. I think that, from what I understand, is a bigger need than might be the characteristics of the pile itself.
Mm-hmm. And I would agree with that point, and I couldn't really talk to sort of specs like that, but there are companies exploring the ability of using woody agricultural waste into converting into products like hydrogen, renewable hydrogen. One, Clean Energy Systems, which you might be interested to look up, is really sort of, I guess, the furthest along, as far as I know, in California. So that's things like old almond trees and others that are sort of follow a regular cycle of being pulled out every 10 or 15 years by a farmer. That could be, and you can sort of sequence the amount of almond trees that come out with the facility intake, and couldn't talk about the specifications there.
Here's one for today and tomorrow and the next day here in California. What does California's challenging experience with its large carbon offsets program tell us about the viability of carefully managing nature-based carbon removal strategies in the face of massive climate risks to Western forests? We're dealing with this one every day here. Ethan or Sam, who wants to start with this one?
Well, there are a lot of concerns around the offset program. I mean, mainly, are we sure that the reductions that are happening, are they additional? Would they have actually have happened anyways? So that's, that's always a concern, and that we don't have often great answers or great ways to document that these are truly additional reductions or savings in this case that would have happened. So that is potentially an issue with nature-based solutions. Do we give credit for someone for not developing an area and then give that area credit, or that owner credit for the carbon that remains sequestered in the ground, when we're not even sure if there would have been development anyways? So I think there is some kind of carryover in terms of the concerns around nature-based solutions in our current offset program. I mean, you think about forests. We've agreed not to cut these trees down, and then now you pay us not to do that. Well, maybe there really wasn't any realistic potential that those trees were going to get cut down, just as sort of classic example. So I think this is going to really speak to how we do the program design, how we verify it, verify the reductions or the sequestration value. So I think all that has to be, those are good questions to raise, and has to be informing the program design.
Mm-hmm.
I wanted to jump in before we're done with a question that was toward the bottom that we've kind of tangentially talked about. It was a question about the environmental justice implications, right, of these things, and it refers to the EJ letter that was recently promulgated from 500 groups. It talks about some of the EJ considerations, including the implications of enhanced oil recovery for frontline communities, pipeline accidents, and things of that nature. I guess my question is that even if we have this process where we're listening at the table, at the end of the day, from a substantive perspective, how do we address those EJ considerations, including the fact that it may allow us to perpetuate fossil fuel production with its negative impacts on impacted communities in the future?
Well, this is, these are one of the key controversies that I raised, in my initial remarks, that this, we don't want this to be an excuse for ongoing industrial pollution. We don't want this to be an excuse for enhanced fossil fuel production. I mean, those are not the ideal scenarios. At the same time, if we want to see some of the true, carbon and EJ beneficial projects move forward, we do have an opportunity to take advantage of some of the expertise from the oil and gas industry. But that's a delicate balance that has to be struck. So this is why, we say demonstration projects with community outreach, and then let's get the data. Let's find out how these projects are moving forward. But I think at this point, including the communities, the affected, stakeholders in the planning process is really critical. And then let's look at the data and let's see what happens here. But otherwise, there's a room for policy to really, distinguish between the projects that we want to see move forward versus those that are going to be less favored because they could potentially perpetuate ongoing environmental justice harms.
Mm-hmm. And I'll just quickly add, I completely agree. Our interest in removal is certainly not to perpetuate fossil fuel use. We disagree that needs to be the case, and that it's sort of unfortunate that it can be, I guess, seen that way, where sort of everything is needed, and this is a piece of the puzzle, a smaller piece compared to other technologies also. And I think that one specific suggestion I would say is on that justice point is I think we could do a much better job at describing what these technologies are, how they work, what their risks are. Every technology has risks, and with communities at a regional and local levels. I think they're not as well understood as other technologies, and I think we could do a much better job at communicating the pros, cons, risks and benefits of them.
Okay.
Will, if I could just add in too, Carbon 180 has a very interesting report on all this that just came out this week called Removing Forward. Highly recommended. Will, I'll turn it back to you.
All right, thank you very much, Bruce. So we are at the top of the hour. So at the outset, I'd like to thank our two speakers, Ethan Elkind and Sam Udan, for their excellent presentations. I'd like to thank Bruce for co-hosting with me this time. And as always, the audience for your excellent questions. This webinar will be archived and available in a few days on the Institute's website. And we anticipate having several webinars in September and moving forward. And we hope you can join us again. And if you haven't already, please join our mailing list to receive information on reports and events of this nature. And once again, thank you, everyone, and have a good rest of the day. Goodbye now.